Okay, hi everyone, welcome back to this video series on Cisco ASA Firewalls, Chapter 6, IP Routing, Configuring Static Routes. Deployment and configuration of static routes is appropriate when the Cisco ASAs cannot dynamically build a route to a specific destination. This may be because the device to which the Cisco ASA is forwarding the packets might not support any dynamic routing protocols. Another example when static routes are appropriate is when the network topology is small and uncomplicated. Static routes are easy to configure, however, they do not scale well in large environments. Dynamic routing protocols such as RIP, OSPF and EIGRP must be considered if the network is fairly large and complex. It is strongly recommended that you have a complete understanding of your network topology before configuring routing in your Cisco ASA. A best practice is to have a network topology diagram on hand to refer to when configuring your Cisco ASA. Figure 5.1 shows a simple static route topology that includes a Cisco ASA with two interfaces configured, outside and inside. So the goal in this example is to configure a static default route for the Cisco ASA to be able to forward packets to the internet through the internet router. Additionally, the Cisco ASA must be configured with a static route on the inside interface to be able to reach the 10.10.2.0/24 network. To complete these tasks, the Cisco Adaptive Security Device Manager, ASDM, complete the following steps. Step 1. Launch ASDM and log into the Cisco ASA. 2. Navigate to Configuration, Device Setup, Routing, Static Routes. Step 3. Click on Add. Step 4. The dialog box illustrated in Figure 5.2 is shown. First, add a default route to the Internet router 209.165.201.2 as shown in Figure 5.2. Step 5. Select the outside interface under the interface field. Enter 0.0.0.0 in the IP address field. Step 7. Enter 0.0.0.0 in the netmask field. Step 8. The IP address of the internet router is 209.165.201.2. Enter 209.165.201.2 in the gateway field. Step 9. Leave all other options with their default values and click OK. Step 10. Add a static route so the Cisco ASA can reach the 10.10.2.0/24 network. To do this, navigate to Configuration, Device Setup, Routing, Static Routes. Click on Add to add a new static route as shown in Figure 5.3. Step 11. Select the inside interface under the interface field. Step 12. Enter 10.10.2.0 in the IP address field. Step 13. Enter 255.255.255.0 in the netmask field. Step 14. The IP address of the inside router is 10.10.1.2. Enter 10.10.1.2 in the gateway IP field. Step 15. Leave all other options with their default values and click OK. Step 16. Click Apply to apply the changes to the configuration. Step 17. Click Save to save the configuration on the Cisco ASA. Static route monitoring. Initially, there was no mechanism for determining whether a route was up or down on the Cisco ASA. Static routes stayed in the routing table even if the next hop gateway became unavailable, and they were removed from the routing table only if the corresponding interface went down. The ability to track the availability of a static route and installing a backup route was added in Cisco ASA software version 7.2. The security appliance does this by associating static route with a monitoring target that you define. It uses ICMP echo requests to monitor the target. If an echo reply is not received within a specified time period, the object is considered down and the associated route is removed from the routing table. A previously configured backup route is used in place of the removed route. The network topology illustrated in figure 5.4 shows a Cisco ASA configured with 3 interfaces: inside, outside, and DMZ. The goal in this example is to configure the route monitoring feature to track the default route to the Internet Service Provider ISP number 1 connection. If the connection to ISP number 1 fails, the Cisco ASA should use the connection to ISP number 2 in the DMZ interface. So you can see here, figure 5.4 route monitoring example. In ADSM, configure route monitoring as follows. Step 1. Navigate to configuration, device setup, routing, static routes. Click on add to add a new static route, or edit to edit an existing route. Step 2. The dialog box illustrated in figure 5.5 is displayed. In this example, the default route is edited. To enable route monitoring, select the tracked option as shown in figure 5.5. Step 3. The track ID is a unique identifier for the route tracking process. The number 1 is entered in this example. Step 4. The track IP address defines the target host being tracked. Usually the IP address of the next hop gateway for the route is defined here. However, this could be any host in the network of the interface where this route is configured. In this example, an upstream IP address residing in ISP1 network 209.165.201.2 is entered. Step 5. The SLA ID is a unique identifier for the SLA monitoring process. The SLA process is used to monitor the availability of the IP address defined under the track IP address option. This allows the Cisco ASA to use a pre-configured backup route. In this example, the value entered is 123. Step 6. The target interface is the interface where the selected host resides. In this example, the outside interface is selected. Step 7. You can specify how often the Cisco ASA should check that the tracking target is reachable by using the frequency field. The default value of 60 seconds is used in this example. However, you can configure this value from 1 to 604.800 seconds. Step 8. The threshold fields enables you to specify a lifetime in milliseconds for this route. The default value is used in this example is 5,000 milliseconds. Step 9. The timeout field enables you to specify the amount of time the Cisco ASA waits for a response from the tracked host. The default value is used in this example is 5,000 milliseconds. However, valid values are from 0 to 604.800.000 milliseconds. Step 10. The Cisco ASA uses Internet Control Message Protocol ICMP echo request packets to verify that the tracked host is alive. The data field size specifies the size of data payload to use in such ICMP request packets. The default value of 28 bytes is used in this example. However, the value can be any number from 0 to 16384. Step 11. The TOS field enables you to specify a value for the type of service byte in the IP header of the echo request. The default value of 0 is used in this example. However, you can specify any number from 0 to 255. Step 13, you can specify the number of ICMP echo requests to be sent for each test packet by using the number of packets field. The default value is used in this example, 1 packet. However, this can be any number from 1 to 100. Be aware that specifying several packets per test may have a direct impact on network performance. Step 13, click OK on the Route Monitoring Options dialog box. Step 14, click OK on the Edit Static Route box. Step 15, the dialog box shown in figure 5.7 is displayed. This is an informational message that reminds the administrator that the primary route is set up for tracking. Subsequently, you should define another route, the backup route, with the same parameters but with a higher metric value on the chosen interface as the backup interface, in this case the DMZ interface. So example 5.1 shows the CLI commands sent to the Cisco ASA from ASDM. You can see here. Display the routing table. To display the Cisco ASA's routing table in ASDM, navigate to monitoring routing routes. Alternatively, in the CLI, you can use the show route command in the Cisco ASA's routing table and verify the configuration. Example 5.2 shows the output of the show route command after the previously mentioned static route statements have been configured. You can see here the letter S by each route statement indicates that it is a statically configured route entry. The letter C indicates that it is a directly connected route. The first number in the brackets is the administrative distance of the information source. The second number is the metric for the route. Administrative distance is the feature used by routing devices to select the best path where there are 2 or more different routes to the same destination from 2 different routing protocols. RIP. RIP is a fairly old interior gateway protocol, but it is still deployed in many networks. It is typically used in small and homogeneous networks. RIP is a distance vector routing protocol and is defined in RFC 1058 Routing Information Protocol. Its second version is defined in RFC 2453 RIP version 2. RIP uses broadcast or multicast packets depending on the version to communicate with its neighbors and exchange routing information. It uses the hop count methodology to calculate its metric. Hop count is the number of routing devices that the packets forwarded by a router or a Cisco ASA, in this case, will traverse. RIP has a limit of 15 hops. A route to a network that is directly connected to the Cisco ASA has a metric of 0. A route with a metric A route with a metric reaching or exceeding 16 is considered unreachable. Two versions of the RIP routing protocol are available. Cisco ASA supports both versions. RIP version 1 does not support classless interdomain routing, CIDR, and variable length subnet masks, VLSMS. VLSMS enable routing protocols to define different subnet masks for the same major network. For example, 10.0.0.0 is a class A network. Its mask is 255.0.0.0. VLSM makes it possible to divide this network into smaller segments, i.e. 10.1.1.0/24, 10.1.2/24, etc. Because RIP v1 does not support VLSM, no subnet mask information is present in its routing updates. RIP uses various techniques such as hold downs, count to infinity, split horizon, and poison reverse to prevent loops. RIP version 2 supports CIDR and VLSMs. RIP v2 also converges faster than its predecessor. It also supports peer or neighboring authentication, plain text or MD5 authentication, which provides additional security. RIP v2 uses multicast for communication between peers, in contrast to RIP v1, which uses broadcast. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.